Hi, welcome to my video on introductions to graphing polynomials. Polynomial graphs. What I'm going to do here, I have a axes of x and y. I have an equation y equals x plus 4. And in the previous unit, we note that y equals mx plus b, and m is 1, which is the slope, and b is -4, which is the y-intercept. Make that a -4. And we plot the y-intercept of a -4, let's say right here. And the slope is up 1, right 1, up 1, right 1, up 1, right 1, up 1, right 1. So this line is linear, notice. And notice the slope is positive, +1. And positive means it's moving up to the right. So you say, well, why do I have the same equation again? Well, I'm going to look at this equation from the point of view of the intercepts, x-intercepts. So if you see x minus 4, when x is 4, y is 0. When x is 0, y is -4. So let's pretend that's way down here, and we have this line. So we get the same line, but we do it from the point of view of x and y-intercepts, especially the x-intercepts. So we get the same line. Again, I'm looking at it from the point of view of the x-intercepts and the y-intercepts. So notice the line. Again, this is positive and is moving up to the right. Now we have, and notice also this is degree 1, so this is a linear. So it's a linear polynomial. Notice now we have y equals x minus 2 times x minus 4. And if you let x equal 2, y becomes 0, because 0 times 2 minus 4 is -2. So if you put 2 in here, you get a 0. So y becomes 0. So the x-intercept is 2. And if you put x is -4, or sorry, x is 4 here, you get a 0. 0 times whatever this number is, if you put 4 in, that'd be 2. So 2 times 0 is 0. So when x is 4, which is an x-intercept, you have 2 x-intercepts now. And when you let x equal 0, put 0 here, you get -2. Put 0 here, you get -4. So you get -2 times -4 is 8. So notice that this is positive, and the y-intercept, pretend I'm not worried about exactly like marked off like this. I'm just saying that the y-intercept is 8. So because it's positive right here, that means it's moving up from this x-intercept here like this. It's coming down like this one will come down, and it's going on through, because it's just this is degree 1. There's a linear, like if you think of x minus 4 as a linear moving on through. This is a linear here at 4, comes down, and it bends. It has to go back up and go through this x-intercept, and then and if this was up high enough, it would move on up through like at 8. Let's pretend the 8 is up there. So there's the bend. Again, I'm just doing an illustration to explain. Notice that this has degree 1, degree 2. So if you multiply this by 4, you get an x squared. So this is a quadratic, like a parabola that we practice in the quadratic unit. And now let's go on to the next one. We have x plus 1, x minus 2, x minus 4, so the x-intercept right here is 4. The x-intercept right here is 2. And the x-intercept right here is -1. Remember, what are the values of x that make the bracket 0? That's the x-intercepts. And the y-intercept, when you let x equals 0 here, you get, again, you get a -8. So it's, let's say right here, we say 8, 1 times negative 2 times negative 4 is 8. So again, it's positive, so that means it's going to move up from this intercept like this. And again, that's a single degree 1, so it's moving on through. And same as this, it's moving on, coming down. Then we're not worrying about where the bend occurs. It goes up through, and it keeps going up through until it hits the 8, and then it starts to come down. And notice right here at negative 1, it goes on through. So notice that they're going through here. It's acting like a line. This is like a line going through like that. This is like a line. That's like a line. That's like a line. And when if it goes through one x-intercept, it got to go through the other one, so it has to bend and come around. Okay, let's continue. Now we have 4 brackets. So the x-intercept here is 4. The x-intercept here is 2. The x-intercept here is negative 1. The x-intercept here is negative 3. And what's the y values? If you let x equals 0, you get 8 times 3 is 24. I'm not really worried about the height of this at being, I'm just going to mark that as a 24. Again, the graph is positive, so that means it goes up. It's going up from the 4, like that. And remember, these are all linears, degree 1. So they go on through, come down. It's going to be very similar to that. There it is. And it's going on through. Now it's going up. You got to hit the 24. Now, it has to start. I'm not worried where the bend is, but it's going to go up and come down through the 24. And it's hit the negative 1 on through. Now it has to bend and come back to here. Again, how far down I'm not worried about. And it keeps on going up. So notice through, bend at 24, through, bend, and it keeps on going. And this is 1, 2, 3, 4. So this is a quartic. And notice this quartic has 4 intercepts. Notice that this, oh, I forgot to put it in. This is a cubic. Degree 1, 2, 3, cubic. Notice the cubic has 3 x-intercepts. Quadratic has 2 x-intercepts. Notice the linear has 1 x-intercept. And this time we have, notice that each equation, I'm just extending it to the left. X minus 4 is in each one of them. And then it's an x minus 2 is in each one of them. X plus 1 is in these 3. X plus 3 is in these 2. And then I have a plus 5. So the x-intercepts, again, 4, 2, negative 1, negative 3, and negative 5. And notice there's 5 of them. 1, 2, 3, 4, 5. This is a quintix. A quintix is degree 1, 2, 3, 4, 5. Quintix has a degree of 5 and has 5 x-intercepts. And this is a plus, so it's going up from the 4, the same as here. There it is. It goes on through, it bends. Oh, we got to find where the y-intercept is. And the y-intercept is as 8, and it's going to be a large number, 8, 5 eighths, 120. So I'm not going to mark 100, but you can see that that's where it goes up through. And the y-intercept tells me if I'm drawing it right. Because if the y-intercept is 120, and I started this off wrong, let's say I started it up down here and came up. So it goes on through, it got to go back down through. Now that means that if it's going down here, that means the y-intercept got to be negative. So starting here, which is a plus, it goes down through, makes the loop, goes back up. So 120 is up here, and that means, that tells you that you're okay. It's passing through. If this was drawn the other way, and you went down here, you would have it wrong. So it comes through, goes on down, and bends, goes back up, Goes up, gotta come down through here, so gotta bend. I'm not worrying about where the bending is. The bending is left for the calculus, and we're not doing calculus. So there's the graph off. So notice, and watch me do this. Here's the way I think about it. A linear comes through. A quadratic is another one, it goes through. A cubic is another intercept, it goes through. A quartix is another intercept, it goes through. And a quintix is another intercept that goes through. So every time there's another degree added onto it, you have going through 1, 2, 3, 4, 5. So again, that's a linear. This one right here is a quadratic. This part here is a cubic. This whole part here is a quartic. And then if you bend again, you get a quintic, degree 5. Note, at each x-intercept, the graph goes through from one side of the x-axis to the other. So at each x-intercept, if it starts here, it goes on through. At this one, it's going on through, it's going on through, it goes on through from one side. So if that's negative, this is positive. If that's positive, that's negative. If that's positive, then it's negative. If this is negative, then that's got to be positive. If this is negative, this has to be positive. So it's going on through, because you got an x plus 4. Every bracket is treated as a linear, so it's going on through. That's very important to understand that. Now, let's go through it again, just to make sure. Equation of polynomial in the x-intercept form is this: y equals a, x minus b, x minus c, x minus d, x minus e, etc. You keep on going in degrees. So you have x number of intercepts, but you have 1, 2, 3. This is a 4 intercepts. If you keep going, you get 5 to 6 intercepts. So what about this equation, y equals x plus 3? Now I'm going to answer some questions. The x-intercept is plus 3. And it's, because it's a plus, it's going up from there. So what it means, let me explain. If I put a 4 in here, if x is 4, that means if x is 4, y becomes 1. So 4, x is 4, y is 1. If x is 5, right here, x is 5, y is 2. X is 5, y is 2. So notice if x is, that's 4, 1. That's 5, 2. So that means that as you move to the right, the x is getting positive. The y's are going up and up and up. So that's, because it's plus, it goes up to the right. So now it has one x-intercept because the degree is 1. You come on through and it's coming on down. And it has right here, if you could do the slope on it, when y is 0, x is 3. When x is 0, y is, and again, I have it off. This is supposed to be, and you can see that it's drawn way off because I haven't got the scale drawn. This is a -3 for a y down right here. I haven't got it drawn to scale. So the x-intercept there is x is 3, y is 0. And when you let y equals 0, x is 3. When you let x equals 0, when you let x equals 0, y is -3. I better be careful. When you let x equals 0, y is -3. When you let x equals 3, y is 0. So letting x equals 3, you get the x-intercept. When you let x equals 0, you get the y-intercept. So you let y equals 0, and you solve it, x equals 3. And the degree of this one is a 1. And notice the maximum degree is 1. The maximum number of intercepts is 1. And now what about if you put a is 1 right here. So y equals 1, x minus 3. So a is 1. What about when a is a -1? So what happens here, when you have x is 3, that's the x-intercept is 3. When you put 3 in, you get y is 0. Now, when you put 0 in, so the y-intercept is when you put y-intercept is when it crosses the y-axis. X is 0, so y is 3. So it's going like this. So the y-intercept is when x is 0. So y equals negative outside of 0 minus 3. Negative of negative 3 is 3. So that's 0, 3. Notice this is a negative slope. So it's going up, up 1 to the right 1, up 1 to the right 1, and up 1 to the right 1. And again, not exactly in the right, but that's supposed to be a 3 there. Okay. And notice this time it's going down. Because it's negative, the slope is going down to the right. And this one has only one x-intercept, but it's going down. So what I'm mainly concerned with is that this is going up to the right and coming on down. And because this is negative, it's going down to the right. Positive, it goes up to the right. Negative, it goes down to the right. Keep that in mind. And let's continue. Another equation. This one I got an add-on. The x-intercepts are 3 and 1. And because it's positive, again, it's positive, so it goes up through there. So if it starts up here, it's positive, it goes up. So if we start to come down, it goes through the 3, it bends, and it goes on up, keeps going. And the y-intercept is x is 0, y is 3. So that's 3. So it's a parabola. The x-intercepts are 1 and 3. The y-intercept is 3. The degree is 1 and 1. Degree is 2, which is a quadratic. And the maximum number of intercepts is 2. So notice the degree, whatever degree of the equation is, then that tells you the maximum number. It could have less, but this is the maximum number. And what about if you have a negative instead of a positive? That means if the x-intercepts are the same of 3 and 1, but because it's negative, the parabola is down here. Parabola it's going down from here. And so if it's going down, I start here. I know it's going down this way, so I reverse it. I come back up. Now I have to do a bend. It's coming back down. And notice now it's turned upside down as a reflection. So when I let x equal 0 in my equation, just work it out quickly. That's negative 3. But actually, if the y-intercept here is 3, because that's the negative of this same equation, so the y-intercept should now be negative 3. So that's a negative 3 right there. But notice it's going down. So on the right, this is a 3, it goes up from here, and then it reverse it. And here at the 3, which is the furthest x-intercept on the right, it's going down from here. So it's a reflection. This is the positive, opening up, like a parabola, opening up. This is the negative, so it's opening down. So notice the direction. Positive opens up on the right, and negative opens down on the right, and then you reverse the flow. Let's continue. And now we have same equation, only added on, where a is plus 1. X-intercepts are 3, 1. X is 0. Again, it's positive, so it's going up, and it's going on through. So here it is, going up like that. So come on down, go through, do a bend, come over, and now there's the 1. Now it's got to go through the 0, so as you move up here, just do a bend on it, and then come down through. So there it is. Notice this is a cubic. Cubic has 1, 2, 3, maximum of 3. So the x-intercepts here are 0, 1, and 3. And the y-intercept is a 0. When you let x equals 0, you get y equals 0. When x is 0, y is 0. 0 times x is 0, 0 times -1 times -3, 0 times any number is 0. The degree is 1, 2, 3. Maximum number of intercepts is 3. And notice this equation is the reverse, opposite, because it's the negative. That means it's going the other way. So the intercepts are still 3. The intercepts are 1. The intercepts are 0. But because it's negative, it won't move through, but it's going down here. Because it's negative, if you put 4, if you take x as 4, if you plug 4 into this equation, the y value will become negative. If you put a 5 in this equation and work it out, the y value is negative. So the further you go this way, the more you go down. And the y-intercept should be the opposite of 0. Well, you can't. Once it passes through 0, the y-intercept is going to be 0. If you let x equal 0 here, 0 here, 0 here, 0 times these numbers will give you a 0. So it's going down, so it's reflected. So it's going down, up, through. Got to come down through the 1. And now I've got another x-intercept. As you go down here, turn and go up. So there it is. These graphs are the reflection of each other in the x-axis, because you're making the y value here is positive, and the y value here is going to be negative. Okay, let's continue. Trying to make sure you understand. It takes a while. I taught for many years, and if you can see what I'm trying to show you here, then it'll all make sense in the end. So we have a is positive, and we have x-intercepts of 3, 1, -1, and 0. Now you might say, well, why didn't you put them in order? Well, when you write an equation, the monomial is always in front of the binomials. The monomials expression x is always in front. So we got a 3, 1, -1, and 0. There they are, 3, 1, 0, -1. Again, this is a plus. So what does a plus mean? It goes up from here. It's going up from this intercept. And remember, they're all linear, so it's going to go through. You go through. It does the bend. You're coming up. Now it's gone up, so it's got to come down. Got to go through. It's coming down, and now it's got to go back up through this one. So it's got to do the bend. So there it is. And this is a quartic. Notice 1, 2, 3, 4. The degree is 4. There's a maximum of 4 x-intercepts. The x-intercepts are 0, -1, 1, and 3. And the y-intercept, when you let x equals 0, 0 times these numbers, y is 0. And this one is the reflection of this. So the same intercepts of 3, 1, 0, -1. But because it's negative, it's going down. So you've got 4 x-intercepts, so it's going down. If you look at the furthest x-intercept on the right, here's the furthest x-intercept in this equation. If it's positive, it'll go up from there, like this, moving on through. If it's negative, it'll go down like this. And so here we go. It goes through, bends and comes down, goes through, bends and goes up, goes through, bends and comes down. There it is. So it's a mirror image. And the y-intercept of this one is also 0. Because when you let x equals 0, y becomes 0. notice you got an M and a W. That's, I always say McDonald's and Wendy's, as in burgers, but that's in when we're in Canada or in the States. So we have the same equation again, only an extension. So we have the x-intercepts of 3, 1, -1, -3, and 0, because you take the opposite. Remember, when you put 3 in here, if you put 3 in the place of x in all of these, because this is a 0, then this product will be 0. If you put 1 in this expression here, you'll get a 0. So no matter what this number is, 0 times those numbers will give you a 0 for the y. So they're the x-intercepts. So it's a 3, 1, -1, -3, and a 0. So now we have, there they are, make them big enough. And so there's the x-intercepts, and the y-intercept when x is 0, y is 0. And degree is 1, 2, 3, 4, 5. Degree is 5. Degree is 5. That's a quintic, Q-U-I-N-T-I-C. And the maximum number of intercepts is 5. So here we go. It's positive. So here we go. These are all linears, degree 1. So it moves through. So it's going up like that. So here we go. Let's reverse it. Coming down, goes through, bends and goes back up. Goes through, bends and comes down, goes through, bends and goes back up again, goes through, and bends and comes down. So we have 1, 2, 3, 4, 5. Notice these are linears, so they will move on through. And the equation has a negative. The y-intercept is x is 0, y is 0. And the intercepts are still the same, only it's a reflection. So here they are, same as above, only it's turned over. So it's going down like that. So instead of going up, it's going down. So it's reverse. So here we go. Go up, got to come down through, goes through. Now we've got to go up to the intercept. It keeps going up, then it bends, it comes down through, and it bends and goes back up. So it's a reflection of this one up here. Anyway, hopefully you understand what I'm getting at, and it just takes a while. So the pattern for graphing polynomials in the intercept form, which is, I call it the x-intercept form, which is this equation here. The pattern is, and I'm going to follow it, I find the x-intercept and I plot each. And then I find the y-intercept and I plot that. The reason you find the x-intercepts, you find the y-intercepts, you got them all on your graph, you plot them all in, and then you start to say, is it positive? If a greater than 0, that means it's positive. If a is less than 0, it's negative. If it's positive, you start in quadrant 1, which is right here, and you go down to the x-intercept that's on the far right. So let's say this is the x-intercept that's on the far right here. So you would come down, like you start in quadrant 1 and you go down and you go through like that. Now, where you take the bend, if it has another intercept, then you do the bend. If the polynomial is positive, that means a is greater than 0, the graph opens up to the right. So if the polynomial is positive, the furthest x-intercept on the right, it will go up from there. So that means you reverse it and you'll see. If a is less than 0, it means a is negative. It starts in quadrant 4. So let's say this is your x-intercept right here. And a is negative. You see a negative at the beginning of the equation. So that means you start in quadrant 4 and you go up to the x-intercept that's on the far right. And then you decide if you got any more intercepts, if you come down or just keep going. That would be a linear. If it's a quadratic, you have to bend and come down through. So if it's positive, if a is positive, you pick the furthest x-intercept on the right and you go up. If it's negative, you pick the furthest x-intercept on the right and you go down. And again, this is a linear. This is a linear. And just to finish up, if a polynomial is negative, a less than 0, the graph opens down. So notice the graph, the furthest x-intercept on the right, it's opening down. The furthest x-intercept on the right is opening up. So, practice all that. So now, let's put it all together. I have 4 equations. You can't count. See, 1, 2, 3, 4, 5. Here we go. What are the x-intercepts? 2, 1, negative 2. 2, 1, negative 2. Notice it's positive, so it opens up on the far right. So here it is opening up like that. It's going to go up. Why? When you put a 3 in this equation, the y is going to be positive. When you put a 4 for x in this equation, y is going to be positive. So it's going like that. So it comes down through, got to take a bend, and now it's got to go up through. Now, where's it going to cut here? Well, if you let x equals 0, put a 0 in here and multiply, you get negative 2 times negative 1 times 2, you get a 4. So it's going to cut at 4. And I'm not worried again where the 4 is. I'm just going to put the 4 there. It's going to go up and it's going to go through, and as long as it cuts through here, and then it's going to come down and pass through here. So notice that this is a cubic. And again, it has 3 intercepts right now. 1, 2, 3, the maximum number of intercepts. So I'm not working on the maximum. It could have 1 x-intercept, but we're not worried about that yet. Okay, that's the graph. Here we go. What's the x-intercepts on this one? 3, 2, negative 2, 0. Just the opposite of what the brackets are. So we got a 3. We have a 2. We have a negative 2. And we have a 0. And it's negative. What happens with a negative? That means the furthest x-intercept on the right, it's going down. So it's going down here like this. And you check, if you take a 4 and plug it into this equation, then the y value will come out to be negative. And how do you know? Well, if you put a 4 here, that's a negative, positive. Put a 4 here is positive. Put a 4 here is positive. So positive, 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 negative gives you a negative number. So when y is 4, you get the y value. And you can work it out. But I know it's going to go down. So here we go. It's going down here, so let's reverse it. They're all linears, degree 1. So we go through, goes up, comes down. It's linear, it goes through, it comes back up again. It's the x-intercept, goes up, and it's going to come down to the next intercept. So there is the graph. And again, if you let x equals 0, if you let x equals 0 here, what happens? Put a 0 here and a 0 here. 0 times those numbers, you get a 0. So the y-intercept is 0. And we're not worried about what the bends are, where they're bending. That's in calculus. Number 3, we have x-intercepts of 1 and a negative 1. 1 and a negative 1. And it's positive. And when we let x equal 0, put a 0 here and a 0 here. Negative, positive 1 times negative 1 is negative 1. So the y-intercept is negative 1 right there. Let's say that's negative 1. So this is plus. So this furthest x-intercept on the right, it will go up from here. So let's reverse it. Come down. It goes through the y-intercept of negative 1, and then it goes on up. So there's the shape, roughly. Okay. Number 4, we have an x-intercept of 1. Notice this is a linear. There's only 1. So the x-intercept is 1 right here. And we let x equals 0. When x is 0, you get negative 1. Negative of a negative 1 is 1. So the y-intercept is 1. So this is a linear. And notice this is the only x-intercept. So because it's negative, it's moving down. So there it is going down. So it comes back up, but there's no more x-intercepts, so we got to keep on climbing. And there it is. It's linear. And number 5, we have an x-intercept of -2, 1, -3, 2, -1. There's all the x-intercepts. And we let, just to check it out, to see if we draw it right. Because see, if you plot these and you don't draw it right, doing the y-intercept makes sure you do the flow right. So when you let x equal 0 here, when you let x equal 0, you get 1, -2, 3, -1, 2. So just check, you got a negative and a negative positive. So you get, it's all positive now, because these are 2 negatives, so that's positive with the positive. So I got 2 times 3 is 6, times 2 is 12. So when x is 0, I'm saying it's up here. So I'm not really worried about the distance, but I know it's going to cut through here. So here we go. We have the x-intercepts are -2. Sorry, yes, -2, 1. Notice I didn't put them in order. That's a -2, that's a 1, that's a -3, that's a +2, and that's -1. So there they are. I got how many of them? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And because it's positive, it will move up from here. There it is. Going up. This is the furthest x-intercept on the right. Now, if you had 2 x-intercepts over here, it makes no difference. If you had none here, let's pretend that they're not there. Let's say you just had these 3. If you had these 3 x-intercepts, and it was positive, you would start here and go up. Not always going to be on this side. So now it's linear, all degree 1s, 1, 1, 1, 1, 1. So you go on through, bend, go up through, but now it has to keep going up till it goes through the 12. And you bend and you come down, and it goes through, and you got to bend and go up, goes through, then you got to bend and come down, and there's 5 x-intercepts. 1, 2, 3, 4, 5. And notice this is a quintix. Quintix is degree 5. So there's 5, maximum 5 x-intercepts. There'll be less when we move on into more videos. So that's explaining how to graph when you have just x-intercepts, when each bracket has what we call a binomial of degree 1, so it moves on through. So positive moves up from the furthest x-intercept, and negative moves down from the furthest x-intercept on the right. So that brings an end to graphing polynomials. For this video, there's more to come on graphing. If you like my video, click the like button, subscribe button. If you're not a subscriber, visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content. That's the content on my YouTube channel called Math Fully Explained. Bye-bye.